Welcome to the deep dive. Today, we're diving straight into Amazon Redshift, asking that question. Could your architecture choices actually be slowing things down or even costing you more than they should?
That's exactly the question. It's
Yeah.
crucial. And in the next few minutes, we're going to unpack Redshift's engine, that massively parallel processing, or MPP, and really look at the key differences between RA3 and DC2 nodes.
Right. This is the stuff data engineers, tech leads, anyone running Redshift needs to know for real optimization.
Precisely. It's about understanding how your queries actually run and where your data lives.
Okay, let's get right into it then. Redshifts power comes from MPP. You said massively parallel processing. So instead of one machine doing all the heavy lifting, it's like a team effort.
Exactly. A well-coordinated team. When you send a query, Redshift doesn't just run it on one box. The leader node takes charge, slices up that query, and sends those smaller pieces out to a fleet of compute nodes. They all work on their little chunk of the query and their portion of the data at the same time.
Okay, so the leader node is like the project manager?
Sort of, yeah. Or maybe the air traffic controller. It figures out the best plan, sends the instructions, and then gathers the results back from all the compute nodes.
And each compute node has its own slice of the data pie.
That's right. Each one stores a portion of the overall data set. And ideally, it works mostly on the data it holds locally. That distribution is really, really important.
Why is it so critical? What happens if the data isn't spread out well?
Well, that's where you can run into trouble. If the data needed for a query is mostly on one or two nodes, or if nodes constantly need data stored on other nodes,
Right.
they have to talk to each other
Mm-hmm.
a lot. That's network traffic, cross-node communication, and it can really slow things down. It kind of defeats the purpose of having all that parallel power if they're just waiting on each other.
Okay, so good distribution equals good parallelism, less waiting. Makes sense. Now let's connect that to the actual hardware, the node types. What's the story with DC2?
Right, DC2 nodes. Think dense compute. Their defining feature is fast, local SSD storage. The storage is directly attached to the node.
So compute and storage are tightly coupled.
Exactly. And that's great for speed if your data fits comfortably within that local storage and you're querying data that lives right there. Performance can be excellent in those scenarios.
When would that be the best fit then? Like for predictable workloads?
Yeah, predictable data volumes, stable workloads where you know how much storage you need, and it fits. But here's the catch, the limitation.
Okay.
If you need more storage space with DC2, you have to add more nodes, which also adds more compute power. You scale them together.
So even if you just need more disk space, you're forced to pay for more processing power too.
Precisely. It can become inflexible and potentially quite expensive if your storage needs grow faster than your compute needs. You end up over-provisioning compute.
I see the issue. Okay, so how do RA3 nodes change that game?
RA3 is fundamentally different. It decouples compute and storage. That's the headline.
Decoupled. How does that work in practice? Where does the data live?
Well, the bulk of the data lives in Redshift Managed Storage, or RMS, which is basically high-performance managed S3 under the hood. You get this huge, scalable storage layer.
Okay, so data's mostly in S3, but didn't you say local storage was fast? Do RA3 nodes still have that?
They do. RA3 nodes have large, fast local SSDs too, but they act primarily as a cache, a smart cache. Redshift automatically keeps the most frequently accessed data, the hot data, on these local SSDs for speed.
Okay. So you got the scalability of S3, but the speed of local cache for the important stuff. What are the advantages there?
Flexibility, number one. You can scale your compute power up or down independently of your storage. Need more processing for a big analytics job? Add compute nodes. Data volume explodes. Just let RNS handle it. Maybe adjust compute slightly if needed.
And that usually translates to better cost efficiency.
Often, yes, especially long term. You pay for the compute you need and the storage you need separately. It avoids that forced bundling you get with DC2.
But is there a catch? Is accessing data from RMS, even with caching, as fast as DC2's purely local SSDs?
That's the million-dollar question, isn't it? There is network involved for data, not in the local cache. However, the caching algorithms are pretty sophisticated. And then there's AQA.
AQBA, Advanced Query Accelerator.
Yep, that's another piece of the RA3 puzzle. It's essentially a hardware-accelerated cache that pushes some processing closer to the RMS layer itself. For many workloads, especially larger, complex ones, AQA helps RA3 match, or sometimes even beat, DC2 performance.
Interesting. So the perceived performance gap might not be as big as you'd initially think. especially with AQUA in the mix.
Exactly. The intelligent caching and AQUA really work to mitigate the latency of going out to RMS.
Okay, so let's bring this home. For the data engineer trying to speed up queries, or the tech lead managing the cloud bill, what's the practical implication of choosing RA3 versus DC2?
For data engineers, understanding that underlying MPP architecture, how data gets distributed, it's key. Whether you're on DC2 or RA3, optimizing your distribution keys and sort keys helps you maximize parallelism, reduce data scanning. That's always important.
Right, the fundamentals still apply.
Absolutely. But for the architects and leaders making platform choices, RA3 often presents a path to lower long-term costs, definitely better scalability, and arguably simpler capacity management because storage just scales.
So if you're on DC2 now and feeling pinched by storage limits or costs when scaling,
Then migrating to RA3 is something you should seriously evaluate. It's often the more modern, flexible approach for growing data warehouses.
it really boils down to matching the architecture to your actual workload patterns and growth expectations.
You nailed it. Get that alignment right, and you're on your way to faster queries and hopefully a healthier budget.
Fantastic. This has been a really clear, quick dive into a complex area. Thanks for breaking that down.
My pleasure.
And for everyone listening, if you want to dig even deeper, definitely look up more on Redshift MPP, those node comparisons and tuning strategies. And if you need hands-on help, our partners at Curate Partners specialize in platform assessments and team augmentation for exactly this kind of thing.
Yeah, definitely worth checking out. And maybe to leave you with this thought. As your data keeps growing, and it always does, right?
Yeah.
Is your current setup really built to scale efficiently and affordably? Something to think about.